Hi, in this video I'm going to show you how to use Excel to graph data. So you can see right here I have data points for 3 different solids of the same material, and they have different masses and different volumes. I want to graph this data to help me determine the density of this unknown solid. So how can I do that? Well, the way Excel spreadsheet works is the first columns that you highlight for a graph, the first column is going to be X and the second column is going to be Y because it just goes alphabetically. To insert a graph, I can click on the Insert tab and then use this icon of Scatter to insert a scatter plot. And what the scatter plot shows me is these 3 points represent these 3 measurements. So this would be piece number 1, piece 2, piece 3, piece 1, piece 2, piece 3. And right off the bat, I see that they do an attempt with the chart title. Now I can change that chart title and type in the effect on mass from volume. And we know the effect of mass on volume. As the volume increases, so does the mass. And that's why this shows a positive slope. It's also linear because they're directly proportional. Okay. So when one goes up, so does the other. And if I create a linear equation, I'm going to get the density because density is mass over volume. And with the slope of the equation, slope is change in y over change in x. My y is my mass, and my x is my volume. In fact, one of the things I should do right off the bat is add an axis title. So let's start with the horizontal. So how do I know that this is my volume? Because again, x, y, and I could also see it goes from 2 to 10, 2 to 10 roughly. So now I can type in directly volume, and I want to make sure I always use my units. Okay, I could do the same for my y-axis. So go here, axis titles, and go to the primary vertical. But now I'm going to type in mass, and I'm going to put the units of grams. The other thing I can do is I can click on my axes right here, and I can kind of change, the number of decimals and things like that. So right now, under number, it shows that all of these graduations are marked by units of 1. And I see the units of 1 because that's my major unit of 1 right here. And it goes from 0 to 10. Now, if I don't want this many decimals, they're doing 2 decimals because my measurements for volume had 2 decimals. I can change that to 1 just to make it a little bit cleaner on my graph. Now I could double click the y-axis and I'll see the same thing. It's going from 0 to 30 because, my range is 6 to 25. I see that my major units are 5 because 5, 10, 15. So I see 5. The minor would be 1. They have 3 decimal places because that's the precision of my measurement to the thousandths place. But for the graph, if I only want to put 1, I could just type in 1, hit enter, and now it's a little bit cleaner. Now, to me, this doesn't look like graph paper. I like graph paper. So what I'm going to actually add, if I go to chart element, I'm going to add grid lines. And you see that I have major for both the horizontal and the vertical. But I want minor. So I want minor grid lines. I'm going to hit minor. So go to grid lines. I hit the minor for the horizontal. And now I'm going to do minor for the vertical. And what it does, this looks more like graph paper. And then when I click back on the horizontal axis, it shows that my major grid lines, right, are by 1, 5, 6, 7, and my minor are by 0.2. So between 1 and 2, there's 5 grid lines because they're each 0.2. And it's the same. I could look right here and I see it goes from 0 to 30. The major axis is 5. And then the minor grid lines are 1. So 6, 7, 8, 9, 10. So that helps me there. But really, what I really want to show you guys is how to use your linear equation. So I'm going to go to trend line, and I have all these different options. I can make it linear, exponential, a moving average. In this case, it's clearly a positive slope. It's linear. I know it's linear, but I want to pop up more trend line options. It automatically goes to linear. The one thing I want to do is I want to display an equation on the chart. And when I look at this, it's showing me the equation. And when it shows me the equation, it's showing a y-intercept because this y equals 2.5795x plus 0.6592 is showing y equals mx plus b. This is my y-intercept. Now, the problem is I know if there's 0 volume, there should be 0 mass. So what I really should do is set the intercept equal to 0. And when I click this box and set the intercept equal to 0, I notice that my equation changes. So if I don't set it equal to 0, there's an intercept. As soon as I set it equal to 0, there's no intercept. This is a better equation. And I could also look at my line because it slightly shifts. So you want to set your intercept equal to 0. The other thing you want to do is you want to display this r squared. This is basically a correlation. The closer this is to 1, the closer your points are in being correlated and basically being a perfect linear function. So now I can click this, and if I want to make it bigger, I can make it bold, I can make it bigger. So now what I notice is the slope, which again is my rise, my change in y, over my run, my change in x, my change in y is my change in mass, over volume, that's my density. So the density is 2.6716 for my unknown based on my measurements. And now if I want to, paste this into a Word document, I could easily do that. I can just copy this, and then I can open up Word. My Word document's not, oh, there it is. Open up a blank document, and then I could easily just paste that graph. And now I have it in this document, and I can easily submit it in a lab report or on a Canvas website. So I hope this video was helpful. If you guys have any questions, leave them in the comments.